Hello everyone, back tuning in to the 6th Winter 2017-18 update from GavsWeatherVids.com. So, once this update is out of the way, we're pretty much halfway through the winter updates now, can you believe? We started winter updates on the first weekend of September, heading into middle of October now. We're going to release the GavsWeatherVids Winter 2017-18 forecast on the 3rd of December. So, we're pretty much halfway through the update. It's been quite an interesting year of updates so far, and now we're beginning to get towards the sort of business end of the update. So the earlier updates we have a bit of fun, but now, or from now on really, as we get through to November particularly, we have to start thinking seriously about where this winter could be going. So, for this 6th update, we're going to, again, bring everything together that we've been looking at over the past few weeks. So, we'll have a look at things such as solar activity, see what's happening with Siberian snow cover, have a look at the oceans, particularly in terms of ENSO, and we'll begin picking up the story exactly where we left off with last week's 5th update with the QBO. I've got a little bit more information on that. So, running on with that, though, just to say that coming up later on today, we'll have Terry Scully, our good friend Terry Scully. He'll be issuing his preliminary of thoughts for the winter. So that's going to be very interesting. That'll be on Terry's page this afternoon. And then this evening, I think we're going to have a look at Hurricane Ophelia one final time this evening, just to pin down what may happen in terms of ex-Hurricane Ophelia as it heads into Ireland on Monday. So that'll be with you on Stormwatch probably sometime this evening, say around 6 o'clock. And also, of course, this video will be placed on the winter updates page as well, and there'll be a written report. That usually happens in the evening as well. So there'll be lots going on at website today. Do please keep checking back for more. Just say it's going to be a very long update. Of course, all these winter updates are quite long. They've been going on. Last one went on over 15 minutes. We're going to try to make this a little bit short, but we have got a lot of information to put in to this 6th update. So it's going to be quite a long update. You can't watch it all in one go. Don't worry, it'll be kept at website indefinitely, so you can come back and watch your video whenever you want on the winter updates page. And as I say, later on there will be a written summary just summarising everything that we discuss in the video as well, so you can have a read of that if you would like to do that. And without further ado, because we have got a lot to talk about for today's update, I think we'd better get on with it. So we will begin, as I say, picking up exactly where we left off with last week's 5th update. So we finished last week's 5th update with the QBO, having a look at analogues for easterly QBO winters. And this chart you're looking at here is from the University of Berlin website. These white areas indicate the easterly phase of the quasi-biennial oscillation. This is a index that tells you the strength, really, of the zonal flow. So when you're in a westerly QBO, such as you're in these grey areas, they're all westerly QBO winters and years. A westerly QBO is a strengthening of the zonal westerly, so it enhances the zonal flow. If you like an easterly QBO, such as we have there, and such as we have there, and again, such as we have there, an easterly QBO is a weakening of the zonal westerly. Sorry if you know all this already, but I have to assume every time I do an update that people are watching for the very first time, so they might not be familiar with what the QBO is. I have to go through the explanation. That's half of what takes up the time with the videos, really, but all the time I have to explain what we're talking about, because some people might be watching for the very first time. So an easterly QBO is kind of like a weakening of the zonal flow. A westerly QBO is like a strengthening of the zonal flow. So, as we proved last week, I think an easterly QBO does increase the chance of colder winters, but it isn't a guarantee, because there are several, as we saw through last week's analogues, and you do have to check out the 5th Winter 17-18 update to see these analogues, because I'm not going to go through them again for this update. But there are several easterly QBO winters that are mild winters as well. So it doesn't guarantee anything, but it does kind of load the dice a little bit in favour of colder conditions. The reason we're looking at ECQBOs is down here, this white area appearing just here, which is going to be an easterly QBO for the winter of 2017-18. Essentially, this white area will do something a bit like that, and that will be our next easterly QBO after the westerly QBO, which ran a long time, actually. It started in 2015, and it didn't finish until earlier on this year. So we looked at those analogues last year, last update, I should say. And what we proved is that an easterly QBO does increase the chance of a colder winter. But what I was wondering when I did the 5th update and looked at those analogues is whether a lot of the colder winters that we saw within the analogues package, and there were cold winters within the analogues package, but I was wondering is whether a lot of those cold winters might have been coinciding with solar minimum, because we know that in terms of the sunspot cycle that we're currently in, cycle number 24, we are heading very rapidly in towards solar minimum. We are certainly within 2 years of solar minimum. So I had a little chat with our good friend James Acril, and we've had a look at some analogues for easterly QBO winters that are within 2 years either side of solar minimum. So some of these analogues are 2 years before solar minimum, which is where we are now, really. We are certainly within 2 years of solar minimum. Some of these analogues are within 2 years after solar minimum. And of course, we aren't in that particular phase at the moment. We are going into solar minimum within, I would say, within the next 18 months, we should be at solar minimum. So we've isolated out the years that we looked at in last week's analogues to have a look at those winters that are within 2 years of solar minimum. And these winters are winters of 1953, 1954, 1954, 1955, 1962, 1963, very interesting winter there, of course. 1965, 1966, 1974, 1975, 1976, 1977, 1983, 1984, 1986, 1987, 1995, 1996, 1996, 1997, 2007, 2008, and 2009, 2010. Those are the winters that we have taken out of last week's easterly QBO analogues and identified them as being easterly QBO winters within 2 years either side of solar minimum. Now, I'm not going to go through all of those years again, so if you want to see them, do have a look at the 5th Winter 17-18 update. I think it's the best update we've done so far, if I do say so myself. So have a look at that 5th update. Very important update. But I'm not going to go through them again, I haven't got time. But those are the years we've isolated out that are easterly QBO winters that are within 2 years either side of solar minimum. And putting them all together, James has put them all together to create a reanalysis chart. And this is it, putting all those easterly QBO winters that are within 2 years of solar minimum, either side of solar minimum. This is what we come out with, an area of above average heights around Greenland and Iceland, and below average heights to our south. It is a cold looking signal overall, with the jet stream and the flow doing something rather like that. So it is a cold looking signal when with, again, easterly QBO that's within 2 years either side of solar minimum. Now, we've broken this down further to the years that are easterly QBO winters 2 years before solar minimum, and easterly QBO winters that are 2 years after solar minimum. And there is a difference. So these are the years combined that are before solar minimum. These winters are 1953, 1954, 1962, 1963, 1974, 1975, 1983, 1984, 1995, 1996, and 2007, 2008. All of these winters are within 2 years before solar minimum, and they are easterly QBO winters, and this is what the reanalysis of those winters looks like. So overall, it looks like a cold signal because we have below average heights to our south, we have above average heights if we combine all the years over Scandinavia, There is a bit of a complicated factor because we do have quite low heights around Greenland, and we also have a displaced ridge in the Atlantic. So it isn't a straightforward signal for cold easterly winds, because actually with some of these years the Atlantic is quite active. So sometimes this ridge over Scandinavia might not be able to deliver that easterly flow. Sometimes it might deliver more sort of southwesterly or southerly, southeasterly type conditions. This is an important analogue because this is where we are within the solar cycle. We are 2 years, probably 18 months really, but let's say we're within 2 years before solar minimum. If we have a look at the winters, the eastern QBO winters that are 2 years after solar minimum, this is a more clear-cut cold signal. These winters are 1954, 1955, 1965, 1966, 1967, 1977, 1986, 1987, 1996, 1997, and 2009, 2010. And this is a more clear-cut cold signal, actually, the winters after ECQBO winters after solar minimum, 2 years after solar minimum. We have this big area of below average heights, no ridge in the Atlantic, notice, just a big southerly tracking jet stream, really, with these below average heights going down through here, and then a very strong blocking signal to the south of Greenland. Now, again, not every winter with these winters that are coming after solar minimum are cold winters, but I think it is a stronger signal that we have here for these winters that come after solar minimum, within 2 years after solar minimum, these ECQBO winters, to be a greater risk of being cold winters because the blocking is in over Greenland. There's no ridge in the Atlantic, but this is the one that's more relevant to us for this year, this easterly QBO, because we are 2 years before solar minimum, or within 2 years before solar minimum, let's say. It won't be 2 years before we arrive at solar minimum, it'll be around 18 months. So, reminder, it is a signal for a Scandinavian high. It is a signal for below average heights to be to the south. But we have this large area of below average heights around Greenland, which isn't very good news, and we have a ridge in the Atlantic. So I would say it's kind of like 50-50, really, between these winters. Some of them will be cold. We've got, for example, 62, 63 there within the analogues package, and also, of course, 95, 96, that's another cold one. So sometimes these winters will be cold, but not all the time, and there are complicating factors for us for this winter. So that's the QBO reanalysis in terms of the solar cycle. Anyway, talking of the solar cycle, let's get on now with the solar activity section of this 6th Winter 17-18 update. So this is the solar disk on our side of the disk today from solarham.net, and we are spotless today. There isn't a sunspot to be seen. They are designating at Solarham solar activity to be officially at very low levels. Not surprising because there aren't any sunspots on our side of the solar disk. And the forecast next 3 days is to remain at very low levels. This is the GavsWeatherVids Winter Update Solar Activity Tracker from James Aqua. This has been updated just up to today, but well, today I'm doing video, yesterday as you're watching the video, so it's up to the 14th of October. And the trend lines continuing to move downwards. Look, so we had the spike in solar activity, sunspots at the start of September, then crashed down, then lifted things up towards the last stages of September, but October really is trending down to a very low level of activity now, which means that our trend lines, our thick red line and our thick green line, and this pink line up here, which is indicating solar flux, all of the trends are heading downwards into what is a much quieter October compared to September. This is updated up to September now, so this is indicating solar cycle 24 in its entirety. Each sort of orange spot, I think it's orange, each orange spot is an individual month's sunspot numbers. So you see we start here at solar minimum from solar cycle 23 to solar cycle 24. It was a very, very long solar minimum, only very gradually lifting solar activity up. We get our first peak of solar cycle 24 there at the end of 2011. Then we go down to quite a low level, considering it's the middle of the solar cycle, quite a low level of solar activity in 2012, and then that continues in 2013. We get our second solar maximum of solar cycle 24 occurring there at the beginning of 2014. That's the maximum for this solar cycle in the start of 2014, after which we've been gradually trending downwards lower and lower. So we go into 2017 around here, the months of 2017 are just there, at really quite a low level of activity. We're back through most of 2017, back at 2009, 2010 levels. However, quite clearly we get that big spike just there. I mean, it's not big compared to where we are in the peak of the cycle up here, but it is big in terms of where we have been in past few months through 2017 for solar cycle 24. So we get that big spike in activity just there in September. But I reckon when we have a look at this at the start of November, we're going to see this orange line and the orange spot going down again, probably to that sort of level, because it does seem we're having a much quieter October compared to September. And this is comparing solar cycle 12 to solar cycle number 24. That's the old solar cycle from 1878 through to 1890, I think. Remember, I'm reciting all of this off the top of my head. I don't run to a script, so sometimes I do get a bit of brain fade, but I think that's right. So cycle 12 ran from 1877 or 1878 through to 1890. The two solar cycles, number 12 and number 24, have been running very, very closely with one another. The way they come out of solar minimum have been very similar. The solar maximums of both of these solar cycles have been very similar as well. And now the solar minimums, or the drop down into solar minimum, we aren't at solar minimum yet, but the drop downs into solar minimum have been quite similar. This is the latest for solar cycle number 24, just there with that orange spot. And it isn't all that far away from a bit of a spike that occurred with solar cycle 12, this green spot just here. That was a few months before our spike in September, this year, 2017, a few months before. And actually at this point in solar cycle number 12, we was down here, although the spikes continued actually right through to more or less to the end of the solar cycle. We even had quite a biggish spike just there. But this is the true solar minimum of solar cycle number 12. So you can see that quite honestly we are very close now to dropping into the solar cycle for number 24. We're going to do something like that quite shortly, I would have thought, and arrive at this very minimum level of solar activity before very much longer. Big thank you to James Ackrill for keeping all of these charts updated for us as we go through the winter updates. These are all updated from our good friend James, who I know will be watching. And as ever, thanks so much to James for his help with these winter updates. Right, we're going to have a look at the hurricane season next. So this is the Wikipedia page for the 2017 Atlantic hurricane season. This image just here is a very fascinating image. It shows every storm that has occurred through 2017's hurricane season so far, and their individual tracks. I want you to draw your attention to this just here. That's the very latest hurricane, Hurricane Ophelia. So that is a Category 3 hurricane as I'm speaking. With this SIC Winter 17-18 update. It's a Category 3 hurricane, and it's breaking records because it's the furthest east in the Atlantic, northern part of the Atlantic, Category 3 hurricane on record. You see, it is very much at odds and very unusual compared to where most of the tropical storms and hurricanes occur, which are down here. This storm is going to be heading up towards the UK and Ireland tomorrow, Monday, and as I say, later on today I will have an update about it, so keep a watch out for that coming up this evening. But going back to the winter update, so we scroll down. These are the latest numbers from the Wikipedia page for 2017 hurricane season. So for total depressions, we're at 16. For total storms, we're at 15 total storms. For hurricanes, we're at 10. And for major Category 3 or above hurricanes, remember Hurricane Ophelia is the latest one to add to that, we're at 6. And that compares to last week. So everything is up 1 again on last week. So last week we have 15 tropical depression, so we're up 1 to 16. We have 14 total storms last week, we're up 1 to 15. We had 9 hurricanes, up 1 to 10, and we have 5 major Category 3 or above hurricanes, and we're up 1 to 6. So generally everything's shifted up another 1 over the past week. This is a hyper season, and it'll be very interesting by the time we get through to the last stage of November to see where we finish up with this hurricane season and compare it back to some of the past hurricane seasons, particularly at the bigger end of things. We won't bother looking at the weaker hurricane season because there's no point. We'll be focusing in November at the bigger hurricane seasons, seeing whether there is indeed a connection between those bigger hurricane seasons and the chance of some cold winters. The idea behind this is that you get a lot of storms and hurricanes going on in the tropical Atlantic, because what they're doing is distributing heat essentially from the pole to mid-latitudes, they're distributing heat from the tropics through the mid-latitudes and eventually arriving up at the pole. And the idea is that if you get a lot of hurricanes distributing a lot of heat from the tropics essentially to the pole, then later on in the winter that can translate back to an increased risk of northern blocking. Now, something that's quite interesting that's happened with this season, we can go back to 1851 to look at these hurricane seasons. Something quite interesting that's happened is that there's been only 3 years that have done what this 2017 hurricane season has done in terms of having 10 consecutive hurricanes in 10 weeks. So essentially we've had a hurricane every week for the past 10 weeks. And what we can say with that is that the years, there's only 3 of them that have done the same. The years are 1878, 1879, and also 1886, 1887, and also 1893, 1894. Only 3 years have done what this year has done in terms of having 10 consecutive hurricanes over 10 weeks. This is a reanalysis for the winter of 1878, 1879. So it's a hurricane season of 1878, if you like, that did this, had 10 consecutive hurricanes over 10 consecutive weeks. The winter of 1878, 1879, following that hurricane season, looks like this: a very, very strong northern blocking, and of course deep trough just here. It's one of the coldest winters on record. This winter, 1878, 1879, quite clearly a very, very strong blocking signal. That's how the reanalysis looks. Severely cold winter. So the next hurricane season is 1886. That does this 10 consecutive hurricanes over 10 consecutive weeks. Again, this is how the reanalysis is looking for the winter that follows that hurricane season of 1886, 1887. Nowhere near as impressive. It is a colder than average winter. Bear in mind, of course, this is back in the Victorian era, so we are predisposed to cold winters to some degree, but this one, it is a cold winter, nowhere near as impressive as 1878, 1879, but we do something a bit like that with the flow and with the jet stream. There is quite a lot of cold weather through the winter of 1886, 1887, and then the only other winter that did this, or the only other hurricane season, I should say, that did this is 1893, the hurricane season of 1893 had 10 consecutive hurricanes over 10 weeks, and this is how the winter that followed it looks. This is 1893, 1894, when we have a mild winter. This one is a mild one with high pressure there, low pressure to our north and west, and just bringing in quite a strong Atlantic flow. So very inconclusive in terms of that, really. We have one severe winter, one just sort of cold winter, and then one mild winter. So really inconclusive in terms of 10 consecutive hurricanes over 10 consecutive weeks. The thing to keep in mind, though, is that it's very unusual what we've done with this hurricane season to do that. Very, very unusual indeed. There's only been 3. They're all back in the 1800s as well that have done this, going back to the year of 1851. So really very unusual this hurricane season, what's happened so far. I think as we get to November, what's going to be more important than this is to have a look generally at the big hurricane seasons, sort of the top 10 hurricane seasons, and seeing what those top, because this will certainly be within the top 10, may even be a top 5 hurricane season. So it'd be important to have a look at the top 10 hurricane seasons and see what the winters were like that followed those hurricane seasons. And that will be coming up in November, when we know roughly, because you can still get hurricanes actually into December. So we won't be able to definitively say we won't get another hurricane. But by sort of mid to late November, have a rough idea of exactly how active this hurricane season has been compared to past seasons. It put all of those years together, by the way. This is how it looks. There's only 3 winters, 1879, 1887, 1894, and the reanalysis for the 3 combined winters looks like that. Very inconclusive. They are cancelling one another out, really. There's a severe winter there, there's a cold winter there, and there's a mild winter there. I suppose if you have 2 that are on the colder side, one that's on the milder side, you could say it is a little bit favouring a colder outcome. But as there's only 3, I don't think we can draw any conclusions, and they're so long ago, back in the 1800s, that again, I'd be very wary about drawing too many conclusions about that. And so that's the reanalysis part of the video done. We'll carry on having a look next at Siberian snow cover. But I'm just going to pause the video there, have a little bit of a water on my throat. Why don't you go off and get yourself a cup of tea and a biscuit. And we may just, or hopefully we will, meet back here in around 2 seconds' time, when we've all had a little bit of a refreshment. Okay, and welcome back. I just want to make sure that we are actually recording, so let's have a look at that. Yes, we are. So, I hope we're all suitably refreshed and raring to go for the second part of the video. The second part of the SIC Wind 1718 update is going to have a look at Siberian snow cover, and then have a look at the oceans. We've got lots of sea surface temperature anomalies to show you, but I'll get on with that shortly. Let's deal with Siberian snow cover next. So this is how things were looking across Russia and Siberia in terms of snow cover last week, when we did the 5th update. And we was doing very, very well last week. Was around 3 years that were running ahead of us, back to 1998. There's a couple of years that is very close to, and then we was ahead in terms of Siberian snow cover of all other years, with the snow line into central parts of Siberia. Let's have a look at the very latest from the National Ice Centre. This is it. And a bit of a stall has taken place over the past week, quite clearly. So that situation last week, this is the situation now. We haven't made any more progress in terms of snow cover. We've probably lost a little bit, if anything, as well. What do we think? Well, we may have filled in a little bit over here, but conversely, we've lost a little bit from down there. So I think if you was to average out total snow cover distance, you would probably find that we have, if anything, lost a little bit of snow cover over the past week, and we've certainly stalled the snow cover development over the past week. So that's where we are right now, to the 13th of October, when I'm recording the video, of course, on the 14th of October. So that's the situation up to yesterday. Let's have a look back through the archives, see how the current position compares to all years back to 1998. So that's the situation in 1998 on the 13th of October, this situation now. So I think we are behind quite clearly 1998 in terms of total snow coverage. That's 1999, probably close to 1999, maybe, if anything, a little bit behind 1999. That's 2000. I think we're a little bit ahead of 2000 at this point. That's 2001. I think we are quite clearly doing better than 2001, although very different positions, because we was pushing some snow to there at this point in 2001. But I think overall we have more snow cover now compared to this point, 2001. That's 2002. That's quite clearly way ahead of where we are right now in 2002. That's 2003. I think we're ahead of that. That's 2004. Different areas cover, probably if you just average it all out, we are quite close in terms of total snow coverage to this point in 2004. But already by this point, the snow was beginning to get in towards northern parts of Russia and also in towards Scandinavia as well at this point, 2004. That's 2005, probably very close to 2005, maybe a little bit ahead of it. 2006, we're behind 2006. That's 2007. Maybe a little bit ahead of 2007. That's 2008. I think we're ahead of 2008 at this point. That's 2009. This is a really interesting year in 2009. I think overall we are probably ahead of this point in 2009. But notice, by this point in 2009, 13th of October, we are bringing the snow in towards Scandinavia very early to do that. Very interesting year, 2009, of course, followed by the cold winter of 09-10. And I do think the way snow cover built up quickly over Scandinavia through October, very unusually in 2009, was potentially a little bit of an omen of what was to happen in that winter. Other than that, we are ahead this year of 2009. 2010, probably very close to 2010. Really, if you was to take out that little bit of snow patch just there, which I don't think lasted all that long. This is 2011. We're ahead of 2011 as well. 2012, probably very close actually to 2012. 2012 is an interesting year because it didn't make much progress from this through most of October 2012 until the final sort of 5 days when it suddenly surged into Europe and into Scandinavia. That's the kind of thing I may be looking for, letting you into a little bit of a secret perhaps with this, but I may be looking for that kind of thing to happen. A stall, such as we have had over the past week in the snow line here, isn't necessarily a bad thing to happen if by the end of October we suddenly get a very quick surge in snow cover into Europe, and particularly and perhaps crucially into Scandinavia as well. That's the kind of thing I might be looking for later on in the month. Hope I haven't given too much away there. That's 2013. We are behind 2013 quite obviously. That's 2014, way behind 2014. Oops, that's gone wrong. So way behind 2014 as well for the 13th of October. That's 2015. We are behind 2015 as well. And this is 2016 last year. And what do we think with that one? So probably quite close in terms of overall coverage because the areas that I cover are a little bit different. But I would suggest we are a little bit behind 2016 as well now for this year. So really quite a big stall has taken place in snow cover, and from last week when we was generally ahead of most years except for around 3 or 4, instead of being ahead of most years, we are generally a little bit behind many of the years that we have looked at here, or at the very least on a par with some of them. But there are very few years that we are ahead of now. There's a few there that we're ahead of, but not all that many of them. Be very interesting to see how that plays out over the next week. As I say, a stall, such as we've seen over the past week, is not necessarily bad news. But we're going to have to wait and see. I'll have more on, of course, over the next week or two. And then finally, we're going to move on to the oceans, and that can take up the rest of the update. So this is the image from NOAA that we used for last week's 5th update in terms of sea surface temperature anomalies. The 3 areas that we're interested in, of course, are the Atlantic Ocean over here. We've got the Northern Pacific up here. We've got the ENSO region over there. Now, last week we had a stall. Talking of stalling these drivers. Last week had a stall in the development. We thought we were getting a development of a cold event in the ENSO region of La Nina. Let's have a look at the very latest image from NOAA to see what's happened over the past week. This is it. And a little bit of a strengthening again has taken place. So it looks like in the past week, the cold signal, the La Nina signal in the ENSO region is fighting back a little bit. Definite strengthening has occurred over the past week in terms of those colder than average sea surface temperature anomalies. Still plenty of cold water around the coast of Chile down here. So I think we are going to get a weak La Nina for this winter. Say that now. I think it will be a weak La Nina. Whether it goes to moderate, as some of the long-range models were trying to indicate a little while ago, where it goes to a moderate La Nina, I'm dubious about that, and I'm very dubious about getting a strong La Nina. I don't think we'll do that, but I do think we probably will have a weak La Nina in the end. In terms of the Northern Pacific, so maybe a little bit of cooling has occurred around here, and then in the Atlantic, so what we see there is that we have got quite a warm Atlantic Ocean overall. We don't have a tripod, we don't have that three-way band of cold, warm, cold, warm that we look for to be a signal for a negative NEO. We don't have that. We just have a generally very warm Atlantic. Notice how warm sea surface temperature anomalies are around the Azores. That's probably is helping to enhance Hurricane Ophelia and take it up to Category 3 hurricane. Very unusually to get a hurricane of that sort of strength and intensity around the Azores. I think it's these warm than average sea surface temperature anomalies that we see here. Now, just want you to focus up here in the northern part of the Atlantic Ocean. So we've got the Greenland Sea over here, we've got the Norwegian Sea over here. In between, it's the Barents Sea. And this is running very, very warm indeed. I'm very unsure what impacts this could be. So what I want to do for the final part of this video is just focusing on this warm these warm sea surface temperature anomalies, very, very warm sea surface temperature anomalies that we have from Greenland to Norway, covering the Barents Sea. And I said I'd have a look at some past years, and that's what we're going to do right now. So we can go a long way back with the archives at NOAA. We can actually go right way back into the 1980s. We're going to start in 2016. Remember, the area we're focusing on, I know this is a broad map, and your eyes may be drawn to different areas, may be drawn to the tropics, your eyes may be drawn to the ENSO regions, may be drawn to the Northern Pacific or the Northern Atlantic. But what I want you to focus on is the Barents Sea, this area just here from Greenland to Norway. So that's the situation on the 13th of October in terms of the sea surface temperature anomalies for the Barents Sea area this time last year, and it's actually close to this year. The only difference really is that this year is much more intense with that anomaly compared to last year. We're going to go through the archives now. So this takes us to 2015. Always keep at your back of your minds. I'm not going to show you this for every year. It'll make the video too long. Just always keep in your mind how warm this anomaly is. Almost going to red colours there, or probably managing to go to red colours, which is anomalies around 4 degrees above average on the scale. So just keep that in mind, how warm that anomaly is. So this is last year. Quite clearly, we are very significantly warmer than this point last, in 2015, I should say, in terms of that warm anomaly. That's 2014, and we are significantly warmer than that. That's 2013, when it's actually quite cold up there between Greenland and Norway. Quite cold at this point in 2013. That's 2012. And again, very significantly warmer than this point in 2012. That's 2011, significantly warmer than 2011 as well. That's 2010, and it is quite warm up there. If we sort of ignore that little bit of cool up there, the rest of that area is actually quite warm in 2010. Notice we have a tripole, interestingly, as well. We have warm to the south of Greenland. It's cooler here, and then it's warm down there. That's just before the December to remember starts kicking off. That's one of the years that are sort of close-ish, not a exact match by any means, because you have got that blue area that we can't ignore, that cooler area, but it is one of the years that's a slightly closer match, perhaps, to this year. But again, I mean, the warmth that we have up there this year is just totally off the scale, really, compared to 2010. That's 2009, when it's actually quite cold up there for the winter of 09-10. We have it quite cold around the Barents Sea. That's 2008, we're significantly warmer than this point in 2008. That's 2007, after that atrocious summer. It really is quite cold between sort of Iceland and Greenland and Scandinavia on the 15th of October 2007. That's 2006. That's a close-ish one as well. Again, we do have that colder area just there that we don't have right now, but overall quite warm up there. A lot of that, I think, is down to the hot summer that we had, though, in 2006. I'm sure you remember we had a very hot summer in 2006. So you see that generally these seas are very warm. The Baltic over there is warm. The North Sea over here is very warm. So just generally very warm seas, really, as a result of that hot summer that we had in 2006. We can't pin this down, I don't think, what we're seeing this year. Can't really pin this down to the hot summer that they've had in southern Europe in 2017, because it was actually quite a coolish summer up across Scandinavia. So I don't think, unlike in 2006, I don't think this warm anomaly can be blamed on the hot summer. Let's carry on. That's 2005, when we had a very cold Barents Sea at this point in October 2005. That's 2004. Maybe close-ish to 2004 in some degrees. But again, you notice we do get that slice of colder anomalies just there that we don't really have for this year, for 2017. That's 2003. We're very much warmer than 2003. That's 2002, when I think, again, we are warmer than that as well. Although that's another year that is a close-ish sort of match, but the anomalies are much more intense this year compared to 2002. 2001, we are a lot warmer than 2001, and then the scale changes, so now you have to be looking just here in the year 2000. That's got quite a warm anomaly in the Barents Sea, I have to say, in the year 2000, so we might be reasonably close there, but again, it is very much a different intensity of temperature compared to this point in 2000. So there are years that have been warm in the Barents Sea in October, warmer than average in the Barents Sea in October. But it's just a complete different scale, really, this year compared to anything that we've seen, certainly back to 2000. Let's carry on. 1999, we're much warmer. 1999, 1998, much warmer than this point in October. 1998, it's actually quite cold in the Barents Sea. Then that's 1997. Notice the El Nino going on over there. Shouldn't really be pointing that out because we're interested in Barents. Actually, this point in 1997, it is really quite cold between Iceland and Greenland and Scandinavia. 1997, and then that is we go through to 1990. Where have we gone? So we're going to try and go to 1996, which I'm not sure if we're going to be quite able to do. There we go. We've gone through to 1996, and it is quite cold at this point in October 1996 in the Barents Sea. We can go even further back than that. Bear in mind, the further back we're going, we are changing the scale that we're looking at, and these become less and less reliable within the satellite data the further back we go, but we will endeavour to go further back. This is October 1995. Can't look at these now on a daily basis, looking at them just as monthly anomalies. You see we have a really cold Barents Sea before the cold winter of 95-96. Whoops, that's gone wrong. So let's go through to 1994 when it's cold again to the north of the UK in the Barents Sea. That's 1993. Shouldn't really be including these years. Look how cold the oceans are looking. 1993. This is very much impacted by the eruption of Mount Pinatubo, which did have a cooling effect on the oceans in the early 1990s. So 93, 92, and 1991 all have very cold oceans as a result of the eruption of Mount Pinatubo. Although you notice actually in 1992, October 1992, it is fairly warm up there. Although again on a different scale this year compared to 1992. That's 1991. This is 1990 when so it's cold around there, but it is warmer up here. That's a very different looking year in 1990. Not really a match though to this year, 2017. That's 1989. Cold again in the Barents Sea. 1988, and again really totally different compared to this year. That's this year, of course, compared to this year and 1988. Let's carry on to 1987. Quite warm, generally with the oceans in October 1987, and fairly warmish there in the Barents Sea. 1986, it looks quite cold in October 1986, Barents Sea. 1985, again, not really a match to the current position. 1984 is quite interesting. That is warm generally throughout that northern area, so from Iceland, Greenland, the Greenland Sea over here to Norway over here, and the Barents Sea between. All areas looking warmer than average. So in terms of total coverage, that may be the closest. Let's get rid of that. That may be the closest to this year. That's 2017. That's now. In terms of the area, the wide area being warmer than average, that may be the closest that we've seen. But of course the difference is in intensity, because much more intense with the anomaly this year compared to 1984. We go back a couple more years. That's 1983, where it looks very cold in Barents. That's for last year. We can look at 1982, when again does look quite cold up there between Greenland and Scandinavia. So I think the point is there are some years that are warmer than average in terms of the sea surface temperature anomalies up there in the Barents Sea, but there's no year that we can see going back to 1982 that is anywhere near as intense a warm anomaly as we have there in that region. And what the impacts of this are going to be, I'm not sure. If we had that warmth, that level of warmth around here, I think that would be a signal for blocking. If we had that warmth to the south of Greenland, I think that would be a signal for Greenland blocking. But getting the warm anomaly just there, and to such intensity, that's very unusual, and I'm not sure what the impacts of that will be. What I may try and do is see if we can go even further back than that. If we go back far enough, hopefully we might be able to find a year somewhere that has such an intense warm anomaly in that region. So I might try and do that for next week's update. I'm not sure if I'll be able to or not. There is a website where you can reanalyze sea surface temperature anomalies roughly going many decades into the past. I think we did use that for some of the winter updates a couple of years ago. I might if I have time, try and have a quick look at October's going back further than 1982. If we go back far enough, we may, in the end, just manage to find a year that is a match. But certainly very, very unusual to have such an intense warm anomaly up there. Alright, so we're at 48 minutes, just under 50 minutes for this 6th winter update. I wanted this to be a bit shorter, but we had so much to cram in. I did want to show you those years individually. I suppose I've probably gone a bit over the top with that, but I wanted you to see just how unusual that warm anomaly is there. That we've got at the moment to the north of the British Isles. So you've got a clear indication of just how rare things are. And in terms of a hurricane, what hurricane season is doing, that's very unusual as well. And in terms of what's happening in the ENSO region with this really late starting La Nina, that's very unusual as well. So all in all, we are in very unusual territory again for this winter, which is going to make the winter forecast. So I have to release it on the 3rd of December, and all of these unusual developments that we are seeing this year is going to make it very, very difficult indeed. Right, at nearly 50 minutes, I think it's better, we better sign off there. So just say later on today, this video will be placed on the winter updates and forecast page. There'll be a written report that goes with it, probably around 7 o'clock this evening. I'm usually quite late with it. In between then, in between now and then, we're going to have Terry Scully's preliminary winter thoughts. That'll be coming up around 2 o'clock this afternoon on Terry's page. And also, I want to get in a final little update for the remains of Ophelia, which will be hitting Ireland through the course of tomorrow. And at just gone 50 minutes. That's it for now. Thanks for watching.